welcome to AMK Resource World. Your success, our motto. If you have not subscribed our channel, please do subscribe. In this video, we are going to solve few problems on PN junction diode using the relationship of current and voltage of this PN junction diode. Let's go with the problems. Okay, we'll go with a simple problem here. You can see here we have a simple problem. A silicon diode has reverse saturation current, that is IS, that is given here 10 nanoamperes, which is operating at 25 degrees centigrade. We need to calculate the diode current, that is the diode forward current, if the forward voltage drop is 0.6 volt, and we need to assume the value of eta as 2. So what is eta here? Eta is the ideality factor of that device. If you are using silicon, then usually the value of eta will be 2. If the semiconductor is germanium, then the value of eta will be taken as 1. So here, first we will write down the given data from the problem. So the given data is the reverse saturation current IS, that is 10 nanoamperes, and Vf is the forward voltage drop, which is given 0.6 volts, and eta we are assuming here as 2, which has been already given in the problem, right? So here, to find the diode forward current or to calculate the diode current for this given data, so we are going to make use of the voltage and current relationship of a PN junction diode. So always we need to remember this formula when we are solving problems on diodes. So here, what is this equation? This is the diode equation, diode current equation, which is used to find out the current through the diode. Okay, and it also gives the relationship between the forward voltage drop as well as the forward current and the reverse saturation current. Okay, so in this equation, so here we know that ID stands for diode current and IS stands for reverse saturation current. Here K is a constant which is given by 11600 by eta, and Vd is the forward voltage drop across the diode, and what is Tk here? Tk is the temperature in Kelvin. As we can see in the problem, the temperature is given in Celsius, 25 degrees Celsius. So we need to convert that 25 degrees Celsius into Kelvin before we make use of that here in this equation. So we are adding plus 273 so that we can convert this Celsius temperature into Kelvin. So when we convert the Celsius into Kelvin, the temperature is 298 Kelvin here, and all these details, all the data, all the values what we get here, we are going to substitute in this equation. You can see here I have substituted the IS value, which is 10 nanoamperes, that is 10 into 10 power minus 9, and then I have substituted the value of K here, that is K is 11600 by eta, where eta is 2 here, and the value of Vd is nothing but the forward voltage drop, that is already given here, that is 0.6 volts. So I am writing here 0.6, and then Tk, it is the temperature in Kelvin, which we have already calculated. So once we put this here, and then if you simplify this equation with the help of calculator, the result what you are going to get is 1.18 milliamperes. So this is the diode current which is flowing through the diode, which is having these data. We have another problem. Let us solve this problem. So here we have that problem, that is the forward current is given, that is 1.5 milliamperes at 27 degrees centigrade, and we can see here IS is 2.4 into 10 power minus 14, that is the reverse saturation current, and also the neta value is given, that is neta equals 1. That means this is a problem on germanium diode, because the value of eta will be 1 for germanium and it will be 2 for silicon diode. And here what we need to find out, so we need to find out the forward voltage drop across the diode. Okay, let us solve this problem. Let us find the forward voltage drop across the diode. So before we start, always we need to write down the given data from the problem. So here ID is given, that is the forward current of the diode 1.5 milliamperes, and temperature, the temperature at which the diode is operating, it is 27 degrees Celsius. So we need to convert this into Kelvin. So we are adding plus 273 here, so that gives 300 Kelvin, temperature in Kelvin. Okay, and IS is already given here, that is 2.4 into 10 power minus 14, that is reverse saturation current, and eta is 1 here. So already we know the diode current equation from the previous problem. So here we have written the equation. Now we are going to substitute whatever the values we have with us from the problem. So we are substituting the value of ID here, the value of IS, and the value of K here, that is 11600 by eta, and Vd by Tk. So Tk is the temperature in Kelvin, and minus 1. So when we just solve this equation, this gets reduced to this step. Once we get this step, to solve this further, we have to take log on both sides, log to the base e. So if you take log to the base e on both sides, okay, then what happens? Log of e power this to the base e becomes this value, that is the power whatever we have we get here, and log base e of this value will gives us 24.858. and here when we solve this for our Vd, the Vd is the forward voltage drop which we are going to calculate in this problem. So finally we are getting Vd as 0.643 volts. So this is the forward voltage drop across the diode for the given problem. Guys, if you like our video, please like, share and subscribe. We will be bringing more such videos relevant to your topics in our channel AMK Resource World. Your success, our motto.